The relationship between mankind and the use of metals such as gold, silver and copper dates back to the beginning of time. Despite the passing of centuries, copper continues to be in high demand. This metal and its alloys are essential and versatile materials required to meet the needs of today's society and sustainable cities. The upswing in emerging technologies means demand for copper is expected to continue to rise. This entails challenges that must be faced by the extractor and processing industries. Every year, about 15% of water consumed is used in industry, including copper foundries. In addition to high costs, there is concern about water scarcity and overexploitation of aquifers in Europe. Backing the future and the environment. Companies like Atlantic Copper and its partners share this concern. As a result, they have developed RedScope.
Siguiendo la estrategia de Atlantic Copper de mejora continua en el desempeño medioambiental, es por lo que vimos en RedScope una oportunidad para maximizar la recuperación del agua y reducir el consumo en energía.
A project funded by the European Union through EIT Raw Materials. This project evaluates the technical and economic feasibility of a new purification process, whose objective is to maximize the recovery of liquid effluents in copper foundries and the possibility of being extrapolated to related industries. The four partners of this project, Atlantic Copper, Grupo Suez, Tetaqua and IVL, form a strong and competitive team in which each one provides their knowledge in the field of business, industry and research. Together, they have already tested and validated an innovative zero-discharge process at the Atlantic Copper Foundry. Project RedScope. Project RedScope began in 2017 with a preliminary feasibility study, laboratory tests and the search for the most appropriate technologies to achieve these challenges. In 2018, work began on the installation of the prototypes of technologies in a pilot plant at the Atlantic Copper Metallurgical Complex and its operation, the analysis of the operational performance, characterization of the waste, and subsequent selection of the best technologies. In order to work with proven data and that the results could be scaled up at an industrial level, a pilot plant was built in an industrial environment. The objective of Project RedScope is to analyze the technical and economic feasibility of a new process to maximize the treatment of liquid effluents in a copper foundry. It has taken several months for the installation, running trials and tests and evaluation of data in order to define and validate the best alternatives. The pilot phase has lasted from April 2018 to February of this year. How does Project RedScope work? How do we transform almost 100% of liquid effluents into usable water? That is, clean water that goes back into industrial processes in the foundry itself. The water consumed is used in various facilities, where different effluents are generated and are sent to the liquid effluent treatment plant, to be treated by a standard chemical physical treatment. This plant generates a unified discharge that complies with all local regulations and the European Union itself.
El proyecto RedScope nos ha permitido validar y testar tecnologías innovadoras, con las que conseguimos reutilizar casi el 100% del agua que sale de nuestra planta de tratamiento de efluentes líquidos a un coste mucho menor que con las tecnologías tradicionales.
Project RedScope begins at this point. The pilot plant is fed at the exit of the liquid effluent treatment plant. Water passes first through an ultrafiltration process, thanks to the design of an advanced filtration prototype. After this, ultrafiltered water undergoes an advanced reverse osmosis process, comparing two different technologies, Rotec and Desalitec. Rotec works by causing a flow change inside the vessels where the membranes are housed, which reduces dirt and increases the lifespan of the membranes. Desalitec works by generating a flow of permeate water similar to that of fed water, for which it continuously recirculates the rejection, brine, to the feed until the concentration of the brine reaches a maximum reading or the performance of the membranes falls, thus producing its discharge. The advanced reverse osmosis stage achieved a 90% recovery of clean water. The remaining 10% is brine, which goes on to the next phase with the objective of continuing to purify and recover water. That 10% of water is treated with VSEP technology based on vibrating membranes. Of this 10%, half is recovered as permeate, leaving 5% brine, which continues until the next and final phase, evaporation alternative crystallization, applying SaltTech technology. SaltTech is a low-pressure evapocrystallizer that reduces electricity consumption, produces permeate and a highly concentrated or saturated brine stream, which is left to rest to obtain salts with a minimum amount of moisture by precipitation, mainly crystallization and/or sedimentation. This 5% that arrived as brine is mostly transformed into recovered water. This way, only 1% of the initial effluent will remain as salts, thus managing to separate the salts from all the impurities contained in the water.
Para Suez, participar en el proyecto REDSCOPE no es solamente una forma de probar tecnología, es la constatación de nuestra apuesta decidida por la revolución de los recursos y la mejor forma de acompañar a nuestro cliente industrial en su reto de optimización de costes y desarrollo sostenible.
This project demonstrates a clear boost to sustainability, achieving more sustainable copper production and guaranteeing the future of the sector. This project, led by Atlantic Copper, allows for optimal use of raw materials in Europe and will contribute to the current strategy of the circular economy of the European Commission.